All right, focus. 3.7, implicit differentiation. It's kind of it's basically the chain rule that we've been talking about. So if I had y equals 10x cubed plus 6x squared minus 1, and then dy dx is 30x squared plus 12x. Nothing new there. But notice on the left side, I'm finding the derivative with respect to x. On the left side, it is dy dx. But if you have a scenario where you have 5y squared minus 6y equals, I don't know, 10x cubed, and you wanted to find the derivative of this. Well, typically it's y equals something, but here we can't solve for y. Can't get y by itself. I mean, you could factor out y, but it's going to have y in your answer. So the benefit of implicit differentiation is you can find the derivative right now. You don't have to solve for y. You can find it, find derivatives of non-functions. Okay, so if you have a circle or if you have a sideways parabola, that's what this one is, or something like it. You can find the derivative as it's written. So the derivative of 5y squared is 10y, but then we have to find the derivative of the inside, and y is a function of x, so we have to find the derivative of y, which is dy dx. So 5y squared derivative is just 10y dy dx, minus the derivative of 6y is 6, but the chain rule says you have to do dy dx again, and then we have 30x squared. So, stating it simply, anytime you have a derivative of a variable other than what you're taking the derivative with respect to, here we're finding the derivative with respect to x. If you're finding the derivative of y with respect to x, you always have to attach a dy dx. So if we wanted to find dy dx, you could factor it out and then divide, and we have dy dx. Notice that it's in terms of both x and y. So if you wanted to find, let's say you wanted to find the slope at 1 comma, let's see, 10. I'm going to say 1, negative 2, even though it doesn't even land on the initial curve. If you wanted to find the slope at 1, negative 2, you'd have to plug in 1 for x and negative 2 in for y, and you have the slope. That's new. Usually, if we wanted to find the derivative or the slope, and let's say it was at 1, negative 2, you would just choose 1 because that's the only variable that's in our derivative. But if it's implicit differentiation, you have a derivative with x's and y's, you have to plug in both the x and the y. Okay, so it's nice that you don't have to rearrange it. If I wanted to, let's see, an example of that. If I have x squared plus y squared equals 25. And I wanted to, anybody know what the shape of that relation is? It's an ellipse. It's close. It's an ellipse that has major and minor axes the same length. What do we call that? What do you say? Oh, that's right. And an ellipse with just a radius, what do we call that? A circle. We're overthinking it. Okay, this is a circle. So like, if your major axis and your minor axis end up becoming the same length, then it's a radius or a circle. Yes. Okay, we have a circle, radius 5. So that's 5, that's negative 5, and that's negative 5. And what if I wanted to find the slope at 3, 4 and negative 3, negative 4. Okay, so 3, 4 is right there. Negative 3, negative 4 is right there. Okay, so the old way we could do it before implicit differentiation, we could say, well, x squared plus y squared equals 25. So y squared equals 25 minus x squared. So y equals plus or minus the square root of 25 minus x squared. Okay, so we could get the top circle and the bottom circle with the positive square root and the negative square root. And then we could find the derivative of the top. So y equals the square root of 25 minus x squared. Y prime would be 1/2 25 minus x squared to the negative 1/2 times negative 2x. So the derivative is negative x over square root of 25 minus x squared. And we could plug in 3. And we get negative 3 over square root of 25 minus 9 is 16. I have a hard time keeping it there. So square root of 16 gives us negative 3/4. Okay, so what did we just find? We found that the slope of that is negative 3/4. That's the old way of doing it. We like the new way. Okay, so I'm telling you, you're going to like the new way. So back to our same equation. And rather than solve for y, I'm just going to find the derivative as is. 2x plus 2y dy dx, I'm going to go y prime, same thing, equals 0. Solve for y prime. So y prime is negative x over y. Okay, that's good for all points on the circle. It's just negative x over y. We went through all this work, and all we were able to do is find that top equation. We would now have to use the negative square root of 25 minus x squared, find the derivative, and then plug in the negative 3. But this is way easier if we just leave it as is. So if I'm looking for the slope at 3, 4, y prime is just negative 3 over 4. Done. If I wanted to find at negative 3, negative 4, I could just plug in negative x, or negative 3 for x, negative 4 for y. So that's, let's see, 3 over negative 4, so negative 3/4. So if we look on our circle, this also has a slope of negative 3/4. Okay, make sense? All right. Maybe we should try a couple examples of just finding the derivative, because it gets a little tricky when we have to do product rules and stuff like that. So why don't you try find dy dx. All right, let's go with 4y cubed minus 2x equals 10y. All right, try to find dy dx. All right, see how we did here. So 12y squared. Do we like dy dx or y prime? Y prime? Okay. Minus 2 equals derivative of 10y is 10, and then a y prime. So we have a couple of y primes. We need to move them both to one side. So I'll move it over here. I'll move the minus 2 over here. So 12y squared y prime minus 10y prime equals 2. Factor out the y prime. And I guess we could divide them all by 2. Make sense? See, you love 3.7 implicit differentiation. I'll just be impressed if you can say it, implicit differentiation. So how many syllables is that? All right. One last problem. I want you to find d squared y dx squared. Whoa. All that means is y double prime. So if you see this craziness, it's basically dy dx, d dx of dy dx, and you get d squared y dx squared. So find the second derivative. So we're going to...
It doesn't make sense. There's a simple way.
Yeah, I know. So if you find the derivative of dy dx, you end up squaring the d on top. So it's like d squared y, and then you've got dx times dx, which is dx squared. Doesn't mean you should do it that way.
It's just stupid.
It's stupid. All right. Okay, yeah, I know. Let's see. Calculus is not confusing enough. Let's see if we can confuse it even more with some really gnarly notation. All right, so we'll start by finding the first derivative. All right, so it's 2y prime equals 8x plus 8. So y prime equals 8x plus 8 over 2y. So 4x plus 4 over y. All right, so there's my first derivative. But we are seeking our second derivative. So we're going to do another derivative, as it is. So the derivative of the left, derivative of the right, so it's going to be y double prime equals quotient rule, so bottom derivative of the top minus the top derivative of the bottom over the bottom squared. Okay, so but it's not okay to have a y prime in our answer for y double prime because we know what y prime is. We know it is 4x plus 4 over y. So we're going to substitute that in for y prime. So it's 4y minus 4x plus 4 times 4x plus 4 over y Oh, why didn't you tell me I wasn't recording? Oh, I am recording. I'm yelling that. See, that guy recorded. Just kidding. I love my students. Okay, so we have a 4x plus 4, 4x plus 4. So I have a 4x plus 4 squared. And then I guess I would multiply the top and bottom by y. So 4y squared minus 4x plus 4 squared over y cubed. Okay, so there's our answer. Sometimes you'll have problems. There's multiple problems in your assignment where you get to the point, like right here, and you think you're doing pretty well. Check the back of the book or your answer packet, and it is nothing close to what you have for an answer. A lot of times you haven't done anything wrong, but you have to back substitute something in the problem. So we have a 4y squared here. We have y squared defined to be 4x squared plus 8x. So check to see, like back here, what you can substitute in. So I could actually substitute 4x squared plus 8x in for y squared, I could put it right there, and then you would have like a whole bunch of algebra to do on top. I don't know that they would do it in this problem, but sometimes it works out really well and slick. But I'll warn you now that make sure you check back here to see if there's anything you can easily substitute in. Questions? See, look at it, it's 15:19. Oh, it just, nice. Projector kind of freezes.